Hello. Today we're going to be solving rational inequalities. So these are going to be all of these different fraction equations, but instead of equals, we're going to have is less than or equal to or greater than or equal to or whatnot there. It's going to be an inequality. It's going to be somewhat similar to when we did the equations, but it is going to be slightly different because we not only have to check one value, we have to check whole sets of values. When talking about like excluded values and things, remember how you got your answer and then you just double checked like, was this an excluded value or could I actually have this as a solution? So this is going to have to look different because it's an inequality. So the first thing is actually different right off the bat. You're going to get everything equal to 0. And so you're going to move everything on one side. And so you want to make it so that it is one fraction compared to 0. So you're going to move anything over and add and subtract so that you get that one fraction. But you cannot get rid of your denominator. That's the difference here. So what we want to do is we want to find something called critical values. Now your critical values are places on your graph where you can change from being above to being below. So critical values are going to happen both from x-intercepts and also from asymptotes. So we're going to want to go ahead and find your vertical asymptotes, and along that line we'll go ahead and say holes. So any holes and vertical asymptotes, they're going to come from our denominator set equal to 0. These are excluded values, and they will never be included in our solution. Meaning, on a number line, what we're going to do is we're going to do an open circle on the number line, no matter what the inequality says. The other place where we can transition from being our y values being less than 0 to being greater than 0 is your x-intercepts. So you're going to find your x-intercepts, and these ones could potentially be included in the solution depending on your inequality. So if you have a greater than or a less than and there's no equal to, that means this is going to be an open circle. Whereas if you had a less than or equal to or greater than or equal to, this is going to be a closed circle because you want to include the 0 in your solution. Then we're going to draw a number line and do a sign analysis. This might be a new term for you, so we will work through that and write our answer in interval notation following that. So let's try number 1 here. So first of all, everything is all on one side. It is compared to 0, and it's just one fraction already, which is good. We're going to go ahead and factor our denominator. Our critical values are our vertical asymptotes, which in this case would be x equals -3 and +1. And they are also going to be your x-intercept, which in this case is your -2, 0. That's your numerator set equal to 0. So your vertical asymptotes are always going to be an open circle on your number line. Your x-intercepts are dependent on your sign there. So we notice that our sign is just less than and it's not the equal to, so we're going to put an open circle there. On your number line, you're going to put all of those critical values on your number line. So we have -3, -2, and +1. Notice we want to go in order from least to greatest because it is on a number line. All vertical asymptotes, I'm going to do an open circle. For this problem, my x-intercept, I'm going to do an open circle. So the sign analysis says this: all of these critical values are kind of different. They're separating our number line into different parts of the domain. Within each of those parts, our graph is going to either be above or below the x-axis. In order to figure out which one's which, what we're going to do is we're going to take all of our factors. We have x plus 2, x plus 3, x minus 1. And we're going to test numbers in those intervals for each of the factors. So we're going to pick a number less than -3, like -4. And you're going to plug in -4 for x. And what we want to do is we just want to figure out, is this factor going to be positive or is this factor going to be negative if I plugged in -4? So this first one would be negative. This next one would be negative. And that third factor would also be negative. if I plugged in -4. Then I'm going to go to the next interval. I'm going to plug in something like -2.5. If I do -2.5 plus 2, that is still a negative number. If I plug in -2.5 plus 3, that now is a positive number. And the very last one here would be a negative number. I'm going to choose 0. 0 plus 2 is a positive number, and a negative number. And you can really pick any number to test here. As long as it's greater than 1, you'll get the same sign. So positive, positive, and a positive. Now, to figure out the overall positive or negative nature of the expression that we have, look at all of yours that are less than -3. We have a negative number times a negative number times a negative number. Every two negatives make that a positive. So overall, if we have a positive times a negative, our overall solution would be negative at that point. In this next one, we have two negatives. They would make it a positive, and a positive times a positive would remain a positive number. The next one, we only have one negative, so if you do any positive number times a positive number times a negative number, that will stay negative. And lastly, we're going to have a positive number. So what we're going to do is we're going to look at these signs up here in conjunction with our inequality. We want our function to be less than 0. So the types of numbers that are less than 0 are going to be the negative numbers. So we're going to highlight anything that has that negative number. That's going to be our solution then, the -infinity to -3, and then -2 to +1. This would be our final answer. And if you look at your graph, this is where it's below the x-axis, so it should line up. Let's try number 2. So we're again going to find two things, your vertical asymptotes and your x-intercepts. Your vertical asymptote is x equals 1. This is an open circle. It's always an open circle. Your x-intercept is 0, 0. Because our inequality here was or equal to, it's going to be a filled-in circle. We have two critical values. At 1 is open, at 2 is closed. We only have two factors to write down the side x and x minus 1. But we have three intervals to test those on. So you're going to take any negative number, and you're just going to ask yourself, if I plug that in for x, do I get a positive or a negative back out? If I plug in any number between 0 and 1, do I get a positive or a negative back out? And if I plug in any number greater than 1, do I get a positive or a negative back out? Two negatives multiplied give you a positive. One negative is going to stay negative, and our last one is going to be positive. We are looking for where our function is greater than 0. That's going to be all of your positive intervals, however many that may be. So you're going to do -infinity to 0 with a bracket, and then 1 to +infinity. So that's the premise of these inequalities. Let's go ahead and take a look at this one. It is already factored. So what I would like you to do is find your vertical asymptotes and your x-intercepts. Now determine if you're going to have open or closed circles for those. Now put those on your number line. Oops. Okay. So we have two open circles at your asymptotes, two closed circles for your x-intercepts, and we are going to have four factors down the side, 2x plus 1, x minus 4, x plus 5, and x minus 1. We're going to chop our number line up into the different sections. For this one, we have 5 different sections to test. So I'm going to ask you to pause the video and go through and test a different number within each interval in each of those factors and determine positive or negative. So let's check it out and see how it went for us. We have all of our different positives and negatives. Then every pair of negatives is going to end up being a positive overall. So we're going to get a positive, a negative, positive, a negative, and a positive. So everywhere this is less than or equal to 0 would be all of your negative intervals. So we would do from -5 to -1/2 in union with 1 to 4. Now it's not always going to bounce back and forth between positive, negative, positive, negative. It's just these strain of examples so far has done that, but not every single example will do that. So now we get to number 4. This is the first one where we don't have it already compared to 0. So we're going to have to move that fraction to the other side. And we're going to have to find common denominators. So once we know our denominator is going to be x plus 4 and x plus 1, we can go ahead and multiply the numerators and actually go ahead and distribute those. So we get 2x plus 2 and an x plus 4, and then we're going to subtract this. So our new numerator becomes an x minus 2, and our denominator is x plus 1 and x minus 4, which means our vertical asymptotes are going to be at -4 and -1, and our x-intercept is going to be at 2, 0. That one's a filled-in circle. The other ones are open circles. And now we can do our sign analysis, and we're going to do that from our simplified fraction. So then we want all of our positive values, or anything greater than 0. So it's -4 to -1, and then 2 to positive infinity. So compare it to 0, combine your numerators, identify your critical values, and then do your sign analysis. Thank you very much for listening. I hope this helped work together, and if you have any questions, feel free to let me know. Thank you.